Hello everyone. In this video we will look at the pH and importance of pH in our daily life. So in fact this is the part of this chapter where the image that we kept for this particular chapter makes sense. So the scale that we are seeing over here is basically called as the pH scale. So we'll discuss more about this and also see these the pH values of different substances. We can see over here that the gastric juice, lemon juice, apple juice, tomato juice, black coffee, milk, all of them they have a pH value of less than 7. 7 we are marking it as a neutral. And we can see egg, baking soda, hand soap, ammonia solution, bleach, and concentrated alkali solutions, all of them they have a pH value of more than 7. And we see that the range in fact will be from not 1 to 14, it will be rather 0 to 14. That is the range of the pH scale. So we'll talk about this in this particular video. So we'll see what is this pH concept basically, and what is the importance of pH in the regular life. Now pH is nothing but it's a measure of how strong something is, or how strong acidic. So whenever a particular substance is given to us, it may be acidic, it may be basic, it may be neutral. So how acidic is that particular substance, we will be able to understand by using this property or parameter called as pH. We'll discuss more about how do we measure this pH value, but just to give you a perspective of how do we identify the substance, lower the number on the pH scale, the more acidic the substance contains. Like say for example, if we have two substances, for one of them the pH value is 2, for the other one the pH is 10. And what we can say is definitely the one with the pH value 2 will be more acidic. So in terms of pH scale, the substance having a lower value on the pH scale is going to be more acidic. And under the room temperature conditions, the pH scale as such will be ranging from 0 to 14. And 0 will be the most acidic and 14 will be the most basic. The number 7 will be corresponding to the neutral point, as we have seen in the diagram in the first beginning of this lecture itself. The neutral point at room temperature conditions, that is very important. The conditions we are talking about are the room temperature conditions. At these conditions, neutral point will be having a value of pH is equal to 7. Now how the name pH has come? So it has come from the German word potens, means potency or power. So potency or power of hydrogen is where H stands for the chemical symbol of hydrogen. So power of hydrogen or potency of hydrogen is the reason why we call it as pH. So as such, the basic idea of pH is very simple. It's a scale to measure how acidic some substance is. And how do we know is by looking at the value. Lower the value of pH on the scale, more acidic that particular substance is going to be. And the range under the room temperature conditions is between 0 to 14. 0 will be the most acidic and 14 is the most basic. At the room temperature conditions, the neutral point will be corresponding to pH value equal to 7. So this is about the idea of pH scale in a very brief. Now if you look at the substances that we usually encounter, the common acids like hydrochloric acid has got a pH value of approximately 1. Sulfuric acid 1.2. Gastric juices, the juices that are available in the stomach, mainly they also will contain hydrochloric acid, but not that much concentrated. Lemon pH 2.3. We can see all these pH values are less than 7, and all these are the readings at the room temperature conditions. Vinegar, which contains acetic acid 2.8. Soft drinks they contain carbonic acid H2CO3, it contains acids. Apple, grape, tomato, banana, all of them they are acidic in nature. Bread, potato, rainwater. In fact, rainwater naturally itself is mildly acidic because the CO2 present in the atmosphere can dissolve in the water, thereby forming carbonic acid. That's why we can see that it is mildly acidic. Milk is also mildly acidic in nature. Pure water at the room temperature conditions, the pH value will be 7 because we are assuming that it is neutral. Then egg, seawater, ammonium hydroxide, sodium hydroxide, all of them will be having a pH value of more than 7. So we can see how the common substances that we will be encountering have different values of pH. So pH essentially is an indicator to tell us whether the particular substance is acidic or basic. Like, the moment we look at the pH value of say for example grape to be 3.1, since neutral point is 7, 3.1 means it is less than 7. So this particular substance, which is grape here, should be acidic. And if somebody gives us that there is a substance with pH value of say 10.2, then since it is more than 7, it must be a basic. So all of this we are discussing at the room temperature conditions. So this is how we are going to be reading the pH scale. Now let us come to the basic idea of what is this pH scale and how do we measure it. So pH is measured as a mathematical function. So we'll study more about this mathematical function. It is called as logarithmic function. So pH is basically defined by using a mathematical function called as a logarithmic function. Even in 10th standard, we may have introduction to the logarithms and the use of log tables. So what is this mathematical function and how we are going to define pH by using the logarithmic function? First, whenever we take a solution, if it is an acidic solution or a basic solution, we will be having two kinds of ions, H plus ions and OH minus ions, which are dissolved in this particular solution. So we can measure the concentration of H plus ions in terms of moles per liter, number of moles of H plus ions present in 1 liter. And we can also measure concentration of the OH minus ions. This also will be in moles per liter. So concentration of H plus ions we can measure, concentration of OH minus ions we can measure. And at room temperature conditions, whichever solution is present in water, the product of these two concentrations, which we will call as the ionic product of water at room temperature conditions, will be 10 power minus 14. So at the room temperature condition, the product of H plus ion concentration into OH minus ion concentration will be 10 power minus 14. Now what happens is, as we have discussed already before in the case of acids and bases, if you have an acidic solution, then the H plus ion concentration is going to be higher. If you have a basic solution, the OH minus ion concentration is going to be higher. Correspondingly, the other value will be lower, so that the product will be always 10 power minus 14. So if you look at the range will be between 1 to 10 power minus 4, 1 being the highest, 10 power minus 14 being the least. So if say for example H plus ion concentration is 1, then OH minus will be 10 power minus 14. If H plus is 10 power minus 14, then OH will be 1. So this is how we will have the range of the H plus ion concentration and then OH minus ion concentration. Now let us focus on the H plus ion concentration. That is what we are looking at here. If you look at just the H plus ion concentration, what we are saying is it can be varying from 10 power minus 14, that is the least value, up to 1. So this is the least and this is the highest. And we must note that accordingly the OH minus ion concentration will be changing. And pH is defined as a mathematical function minus logarithm of H plus ions concentration. This is how we will define the pH. So what is this logarithmic function? So if we say that pH is equal to minus log H plus, the way we will read it is, if somebody tells us pH is say for example 7, this means 7 will be equal to minus log H plus, and the way we will read the function is H plus value concentration will be 10 power minus 7. If somebody says a pH is equal to 5.5, then the concentration of H plus will be 10 power minus 5.5. So this is how we are going to be looking at the values of the pH and concentration of the H plus ion. So if we have the concentration of H plus ion as 10 power minus 14, if H plus ion concentration is given as 10 power minus 14, then the corresponding pH value should be 14. If H plus ion concentration is given as 1, then the corresponding pH value will be 0. So if we have the highest value of the H plus ion, then the corresponding value of pH will be the least, which is 0. If we have the H plus ion concentration least, then the corresponding value of pH will be highest. So we can see here the pH value for the least it will be 14, and for the highest amount of H plus ion concentration, pH value will be 0. So if you go towards 0, then that would mean that the solution is becoming more acidic. If you go towards 14, then the solution is becoming more basic in nature. So this is about the idea of the pH scale. And for neutral, the H plus ion concentration and OH minus ion concentration both will be equal to 10 power minus 7, and that is what if the H plus ion concentration is 10 power minus 7, then pH value will be equal to 7. So that is corresponding to the neutral point. So somewhere in the middle we will have pH is equal to 7. That is the neutral scale. So this is about the idea of the pH scale. And what we need to remember is, while we will get more clarity about the logarithmic function when we learn about it in the mathematics also, here for us in chemistry, the understanding that we will require is how do we read the pH scale at room temperature conditions. The scale will vary from 0 to 14. 0 will be the most acidic and 14 will be the most basic, and 7 will be the neutral point. So if a solution is given to us, then we can identify whether the solution is acidic or basic depending upon the pH value. So this is the idea of how do we measure the pH. Now the importance of pH in our daily life is very much, not just in daily life but even in some of the biological process that happen within our body, and even in the other organisms, this pH will play a very important role. Like in our blood, we do require the pH value to be maintained in a particular range, 7.35 to 7.45, and we can see that the blood needs to be it's more than 7, means it should be mildly basic. It should not be very much basic, it should be mildly basic. And if there are large deviations from this range, then it is going to be extremely dangerous, because the properties of the blood will be changed. And if you have large deviation, means if you have value more than 7.8 or less than 6.8, like less than 6.8 or more than 7.8, in that range if it is going, then it can even result in death. So that is how critical it is to maintain the pH in that particular range, so that the blood will have its properties. And if you have a condition where the pH drops below 7.35, the criticality will come when it is below 6.8. But if the pH is dropping below 7.35, we actually call that as acidosis, that particular state. And if the pH is rising above 7.45, we will call it as alkalosis, means it is becoming acidic, that's why we are calling the previous case as acidosis, and it is becoming basic, that's why we are calling it as alkalosis. And the corrective measure has to be taken so that the pH will be brought back into the survival range, which is 7.35 to 7.45. So the pH value to be in that particular range is vital for the blood to have its basic properties. And as we have seen, the cause of certain monumental structures like the Taj Mahal to lose its shine is also attributed to what we call as the acid rain. Now generally itself the rain, since it contains carbonic acid H3CO3, is mildly acidic. It's not very much acidic, but it is mildly acidic. But if this acid contains say for example sulfuric acid or nitric acid, if these kind of acids are dissolved in the rain as it is coming down, then the pH value will be even more lesser. like normal rainwater, if it is in the range of 5.6 to 5.8, it will be even below that, because by the dissolving of H2SO4 and HNO3, which will come from the oxides of sulfur and oxides of nitrogen. When these oxides of sulfur and nitrogen, they dissolve in water, they will give the corresponding acids, and when these acids are mixing with the acid rain and it flows into rivers, then it can cause severe problems for the survival of aquatic life, and even when this rain is falling on the monumental structures, we see that they will basically lose the shine, the property of the marble will get affected. So these are some of the effects of the acid rain. So acid rain is basically caused because of the presence of sulfuric acid and nitric acid. Mainly the sulfuric acid will come from the burning of the fossil fuels. I mean, sulfuric acid will not directly come. What will come is the oxides of sulfur. They will be getting into atmosphere and they will dissolve in the rainwater, thereby they will form the acids of sulfur. And nitric acid will come from the vehicle exhaust. So near the vehicle exhaust, the nitrogen and oxygen in the atmosphere, they will combine to form oxides of nitrogen, and these oxides of nitrogen, when they are dissolved in the rainwater, they will form the acids that contain nitrogen, like nitric acid, and these two are the reason for the acid rain to happen. Now one more important area where we will observe the importance of pH is the tooth decay. Now tooth decay starts when the pH of the mouth is lower than 5.5. So if you look at the tooth enamel, it is made up of calcium phosphate. So calcium phosphate is Ca3PO4 twice. Tooth enamel is made up of the calcium phosphate, which is a very hard substance in our body. And the bacteria present inside the mouth, they produce acids by the degradation of sugar and food particles. So whenever we are eating, after the eating is over, there will be some sugar and food particles that are remaining inside the mouth, and the bacteria will degrade it and it will produce acids. And because of these acids, the pH will become less than 5.5. And as a result of it, we will see that the tooth decay starts. And the best way to prevent this is to clean the mouth after eating, and this we can do by using a toothpaste. So generally most of the toothpastes will be basic in nature, and what essentially happens is when we are using a toothpaste, then they will perform the neutralization reaction. So whatever the excess acid that is being produced by the action of bacteria, it will be neutralized, and thereby we can prevent the decay of the tooth. So the tooth decay happens because of the pH becoming lower than 5.5, and that happens due to the producing of acids by the bacteria, and we can prevent it by cleaning the mouth with a toothpaste. Toothpaste generally will be basic in nature, and what exactly happens, there is a neutralization reaction. Now another common area where we'll see the pH importance is the indigestion problem. Now our stomach, generally the gastric juices, they contain hydrochloric acid, so it's acidic in nature. It will not be a concentrated acid, but it will be a dilute acid. Now these acids, they actually help us in the digestion of food without of course harming the stomach, so they will help in the basic digestion of the food. Now during the indigestion, what actually happens is the stomach produces too much of an acid, and this will cause pain and irritation. We also call it as sometimes commonly acidity. Now to get rid of this pain, we use particular bases, we call them as antacids, and one of the examples is magnesium hydroxide, which we will generally refer to as milk of magnesia, which is a mild base. And what these antacids will do essentially is they will perform a neutralization reaction. So whatever the excess acid that is there, there will be neutralization of the excess acid, and thereby we will stop having that pain and irritation inside our stomach. So this is how we can rectify the indigestion problem. Soil fertility also depends upon the pH value. As such, plants, they require specific pH range for their healthy growth. Like most of the metabolic processes, they happen under some conditions of pH and even temperature. So suitable conditions of pH and temperature are required for the metabolic process to happen, and that will be essential for the plant growth. Not just that, even the effect of soil pH will be great on the solubility of minerals and nutrients. Like if you look at before a nutrient is used by the plant, it must be dissolved in the soil solution, and most of these minerals and nutrients are soluble in acid soils than in neutral or alkaline soils. So if you look at these minerals are available, or they are more easily present in the acidic solutions. Phosphorus is never readily soluble in the soil, but is most available in the pH range of around 6.5. So if you look at one of the important elements for the plant growth, phosphorus, we will call it as NPK: nitrogen, phosphorus and potassium. So these are three important elements for the growth of plants. So phosphorus is not readily soluble in soil, but if we have a pH value which is around 6.5, mildly acidic, not very strong acidic in nature, this will be easily able to dissolve in the soil. If you look at the extremely strong acidic soils like pH 4, 5, then they can have a high concentration of aluminum, iron and manganese, which may be sometimes toxic for the plant growth. So we require mild acidic soil solutions, so that the important elements like phosphorus and the others, they will be readily available, or they are easily able to dissolve. But if the pH value is becoming very much less and getting into the range of strong acidic solution, then it can cause problems like the aluminum, iron and manganese, which are toxic to the plant growth. They might get absorbed by the plants because they will be available in that particular concentration range. So for the plant growth to happen as such, the pH will play a role in two areas. One is inside the plant, for the metabolic activity to happen, the pH should be in a particular range for the healthy growth of the plant. And second, also for the better absorption of the nutrients and then minerals, the pH in most of the cases should be mildly acidic, but it should not be too acidic, which can again be a problem. And the soil pH can also influence plant growth by its effect on activity of beneficial microorganisms. Now the plant growth is not just about plant absorbing the minerals and nutrients, it is also about the activity of some beneficial microorganisms. Like there will be bacteria that will decompose soil organic matter, and they make it easy for the plants to absorb it. Now if you have strong acidic soils, then the strong acidic soils, they will hinder the activity of the bacteria, so which essentially do the breaking of the organic matter. So if the bacteria activity is hindered, then it is going to in turn affect the plants. So this will basically prevent the organic matter from breaking down, and that will result in the accumulation of organic matter and tie up of nutrients. Particularly this will happen for things like nitrogen. So we have nitrogen decomposing bacteria. They will facilitate the easy absorption of nitrogen and nitrogen compounds by the plants, and if that is being hindered, then it is going to affect the plant growth. So as such, we see within the plants we need to have pH in a particular range, that is for the general development of the plant growth, that is inside. And soil pH, we will require it to be mildly acidic. So it should not be neutral, it should not be basic, and it should not be strong acidic also, because there are again problems with it, because it will make toxic metals like aluminum and iron to be absorbed by the plants, manganese, and also it will prevent the activity of some beneficial bacteria, like the bacteria that will help in the absorption of nitrogen by the plants. So this is about the importance of pH in the soil fertility and the plant growth. So this is about the idea of pH and importance of pH in our daily life.